Section 11.6. Our objective today is I can use formulas for arc lengths and areas of sectors. So remember that an arc is formed by two radii. So we have OA and OB, and so that cuts off an arc. And that arc can be described by two different numbers, okay? The first one is the one that we've been used in the past, is the measure. Measure of arc AB is always in degrees, and that's what we've worked in the past. The second way, or the second type of arc, is the length of an arc. And the length of an arc is the length of a piece of the circumference. So the length is always in terms of some unit of measure, so inches, feet, centimeters, meters, whatever it is. So notice that it's a part of the whole circumference, okay? We also want to be able to determine the area of a sector, okay? So first of all, a sector of a circle, is the part of the circle so it's kind of like if this was a pie, this piece of the pie is what you took out and ate. So in geometry, refer that to as the sector of a circle. So it's the area bounded by two radii and an arc. Okay, so we have OA and OB, and we have arc AB. So when we're talking about sector of the circle, we're talking about area. Okay. And notice that the area is a fraction or a part of the whole area. Okay, and so we use that information to be able to determine the area of the sector. So let's go back to the length of an arc, okay? So the length of an arc is a part of the whole circumference, okay? So we use the formula length of arc is equal to the part of the whole, because remember we have measured arcs in degrees. So what degree part of the whole degree is 360, times the circumference, which is 2 pi r. So that's the formula for arc length, okay? And by the same token, if we're talking about area of the sector, okay, again, it's a fraction of the whole area, so it's x over 360, okay, times the area. Okay, so that is the formula for sector, to find the sector of a circle. So let's look at some examples here. In circle O, with radius 6 and measure of angle AOB equals 150. Find the lengths of arc AB and arc ACD. Okay, and then here's the picture that goes with that. Okay, So we have this circle, circle O, and we have, this is point A, this is point B, this is point D, and here's point C. Okay? And we know that angle AOB has a measure of 150 degrees. Okay? So then length of arc AB, okay? Well, first we figure out what the fraction is. So that's going to be 150 over 360, or 5 over 12 if we reduce that. Then we figure out what the circumference is. So that's 2 pi r, and we're told that the radius is 6. So 2 times pi times 6, or 12 pi. And so then the arc length of arc AB will be 5 over 12 times 12 pi, which gives us 5 pi. Okay? Then if I want the major arc, whoops, I forgot to say that this arc was is 18 degrees. Okay? So if I have arc ACD, which is a major arc, okay, well, I need the degrees of that arc, so it's going to be 360 minus 150 plus 18, or 360 minus 168, or 192. Okay, so the fraction that represents that is 192 over 360. Okay, which reduces down to 8 over 15. Then I need circumference. So circumference is 2 pi r. And so we got earlier that that was 12 pi. And now to find the length of that arc, it's going to be the fraction times the circumference, which comes out to 32 over 5 pi. Okay? Example 2. Given this circle with radius of 12, find the area of this sector. Okay, so find the area of the shaded sector. Okay, well, first of all, we need the fraction. So the fraction is going to be 40 over 360, or 1 over 9. We need the area of the whole circle. So the area of the whole circle is pi r squared, so 12 squared pi, or 144 pi. And so the area of the sector is going to be the fraction times the area. And if you reduce that, we get 16 pi units squared for our area. All right, and one last example, example 3. We have this picture, we have this circle of radius 4, and this arc length, is 90 degrees. And what I want is the area of that region, okay? Okay, so first we're going to find the area of sector. Oops, let's put some letters in here so we can, of sector AOB. So the fraction is going to be 90 over 360, or 1 over 4. The area of the whole circle is 4 squared pi, or 16 pi. So the area of sector AOB is equal to 1/4 times 16 pi, or 4 pi. Okay, so let's box that because we're going to need that later. Okay, then that's too much area because that includes everything. So then what I need to do is find the area of this triangle. Well, that triangle happens to be a right triangle because we know this is a central angle, it has 90 degrees. And so this is the height and this is the base. So area of the triangle is 1/2 base times height. So the area is 8 units squared. Okay? So now I need to subtract that from the area of the whole sector. Okay? And what's left over will be the area of the shaded area. So I'm going to do area of sector minus area of triangle will equal area of shaded region. Okay, so the area of the sector was 4 pi. The area of the triangle was 8 units squared. And I should say that's units squared also. So that equals the area of the shaded region. And notice that we can't do any more with that. So I'm going to write it like this. So this is my answer. So the area of the shaded region is 4 pi minus 8 units squared.